Okay, we've got a normal distribution question here. We're told that Sarah tuning her radio station is normally distributed 433 and a standard deviation of 4, which we square. So she wants a radio station with 440. We want to know the probability that RS is less than her 440. You're going to use your calculators. Remember, equals doesn't mean anything in normal distribution because it's continuous. So the slither is so small, if you ever get asked anything with equals, it's just 0. So we're trying to find the probability S is less than 440. And we get 0.9599. And then we're going to look at more than 5 kilohertz away. So if we think about that, that means it's got to be more than between 435 and 445. Oh, not sure what's happened there. Yeah, 445. Okay. So, but we want everything else. So what we can do is we can find the probability from 435 to 445 and do 1 minus it. And when we do that, we get 0.6928. Okay, so now she thinks it's going to be less than 433. And when she works it out, she gets a mean frequency. This should say 432. So what we're going to do is do the easy bit first. So H0, mu equals 433. H1, mu is less than. Now this is always the same. It's hypothesis, your H0 and H1 you should always get right. And because we've got a sample, we had a sample, I believe, of 20, yes. Then you've got to use this X bar where you write your mean. And then you have your standard deviation squared over your N. So we want the probability this X bar is less than 432. Gives you 0.0368. So 0.0368 is less than 5%. So you've got to reject H0. And you say there is evidence to suggest Zahra is correct. Is correct. And you probably should start by saying reject H0. Right, last bit of this section. We've got Jake is tuning in to get to listen to his music. And we've got a normal distribution. This is going to be our mean. We've got a value of 438 here where everything less than is 0.2. We've got 445 where everything bigger than is 0.1. And what we're trying to do is work out our mean and standard deviation. So what we need to recognise is this is something to do with our Z, which is our standard normal distribution, and our connection between Z and X is X minus mu over sigma. Now the thing to remember, Z is just another axis where we've coded this mean and made it 0. And we're going to use the same logic on the two that underneath. So if we say 445 minus mu over sigma and 438 minus mu over sigma. Now, you don't know what those mean necessarily, but we need to then find out the inverse area to be able to equate it to something. So in your calculator, you could do inverse area and it will, for Z, I mean, it gives it to you on the tables, but if you use inverse calculator on your inverse area on your calculator, you should be able to get there quite quickly. And then we end up with two nice simultaneous equations to solve. So that one equals 1.2816. I'll let you solve those, but you end up with a standard deviation of 3.3, and they want it to 1 decimal place. So your mean is going to be 440.8.